Okay, so we're on example 1.5 now. The curve C has second derivative d squared y dx squared equals 3 minus 6x, and it passes through the point 1, 2, and its gradient at this point is negative 3. Okay, so let me just write that down. The curve C has, passes through 1, 2, and has gradient negative 3. Find the equation of C. Okay, so there's a lot going on here, isn't there? Okay, so the reason why this one's in this booklet is to show you that you can also find the equation of a curve starting from the second derivative. So, recall the notation for second derivative from differentiation, d squared y dx squared. So if you start off with y and you differentiate it one time, you get dy dx, and then if you differentiate again, you get d squared y dx squared. And notice, where the 2 goes here, so it's d squared y and then dx squared. If I differentiate it again, I'd end up with d cubed y over dx cubed. So you have to put a 3 here in the middle, you have to put the 2 here in the middle, not at the end, as you might think. Okay, so what we're going to do is we're going to integrate it one time. Now, if we integrate, you can think of this as like a ladder, right? So if you start from here and integrate it one time, you'll end up there. And if you integrate again, you'll end up there. If you integrate again, you'll end up there. So you can think of it as a ladder going up in like steps. And if you go down it, you differentiate it. So y differentiates to dy dx, which differentiates to d squared y dx squared, and d cubed y dx cubed, and so on. Okay, so we're going to integrate this. So if I integrate it one time, so dy dx is equal to the integral of that. So 3 would go to 3x, minus 6x would go to minus 6x squared over 2, because I'm adding 1 to the power and dividing by the new power. And then I would still need my constant. Okay, so I'm going to call that C. So we kind of called the curve C as well, but if you look closely, it's actually fancy C. So mathematicians do this sometimes. They like to use fancy letters occasionally, but it's not the end of the world if you see it looks like that C as well. Okay, so I've integrated it one time, but it wants the curve that passes through 1, 2. Okay, so there's going to be an issue that we're going to see if I integrate this again to get dy dx, but to get y. But before I do that, I'm just going to simplify this a bit. 6 over 2 is 3. If I integrate it now, I'm going to get 3x squared over 2 minus 3x cubed over 3. And we had an example earlier where we had to integrate a letter, a constant. C is going to go to cx, and there's going to be a new constant, because I always have to add on a constant whenever I integrate, okay? As we saw in the earlier previous video. So I've got this, and there's 2 unknowns, isn't there? So we kind of have the equation of the curve, but at the same time, it's it's kind of like a general equation. We want the specific equation. So how do we go about finding C and D, basically? So we have to use the information the question tells us. The curve passes through 1, 2, and it has gradient negative 3. So that means that this is the equation of the curve now, right at the bottom. This passes through 1, 2, so this has to satisfy 1, 2. So when x equals 1, y equals 2, so I've got 2 equals 3 times 1 squared over 2, take away 1 cubed plus c times 1 plus d. So that's 2 equals 3 over 2 minus 1 plus c plus d. So I'm just working through the evaluation of this. So that's 2 equals 3 over 2 take away 1 is 1/2 plus c plus d. And then, because I've run out of space, ideally I like to work in columns, and you should as well. Because I wrote here, I'm going to just continue here. Okay, so 2 take away 1/2 is 3 over 2. So I end up having c plus d equals 3 over 2. So that's an equation, isn't it, with 2 unknowns. So let's give this a name, number 1. And hopefully your maths equivalent to a spidey sense is tingling here, and you might see where this question's going. I'm not going to spell it out, but I will tell you when we arrive at it. But hopefully you're thinking the same as I am right now. Okay, so we've used this bit of information. Let's use this factoid now. So it has gradient negative 3. So that means when x equals 1, the gradient is negative 3. So at the point 1, 2, the gradient is negative 3. That's what this second bit of information is telling us. So when x equals 1, dy dx is equal to negative 3. So that allows us to go back to this equation and solve for c. So in fact, if we solve this one for c, we can get that value for c and sub it into here. So what I was alluding to before was that this is probably going to become simultaneous equations. However, and usually a lot of these questions do become simultaneous equations. However, this one's a bit easier. Like this is going to allow us to solve for c. Okay, so when x equals 1, dy dx equals minus 3. So I've got minus 3 equals 3 times 1, minus 3 times 1 squared plus c. So minus 3 equals 3, minus 3 plus c. These cancel to 0. I get c is negative 3. So dy dx equals 3x minus 3x squared minus 3. But I didn't really need to write that again. The key is, because I've got c is minus 3, and I've got this here, so I'll call this equation 2, but you know, even though it's a bit easier than simultaneous equations, when c is minus 3, I can do 3 over 2 plus 3, so that's 4 over 5, that's 9 over 2 I get for d. So d is equal to, in fact, let me just get rid of that. So d is equal to 9 over 2. Now this time, I'm going to double check on my calculator. So I'd be interested to see what calculators people are using. This is the one I recommend for A-level maths, Casio CG 50, FX CG 50. However, you can use other calculators such as this one. This is a great A-level calculator as well. This is the FX991EX, and some of you might be using the updated ClassWiz that comes in black. Anyway, so let me type that in. So what am I checking again? Oh yeah, I'm solving for d, so 3 over 2, take away negative 3. So I'm adding 3 basically. 4.5, 4.5, which is the same as 9 over 2. Okay, so final answer is y is equal to 3x squared over 2. And by the way, here's another way you can write 3x squared over 2. You can write it as 3 over 2x squared minus x cubed minus 3x plus 9 over 2. And that is the final answer to this problem.